Hello everyone, welcome to Saras's classes. So in this video, let us discuss the following question. So the question is about the instrumental in Solow's growth model and what are its limitations, right? So we are going to study about the Solow growth model. So let us first discuss what Solow growth model is, okay? So Solow growth model is basically an exogenous model, okay, where we assume that the technology is exogenously given and it is not determined within the system. So this is one of the assumptions. Apart from that, the production function exhibits constant returns to scale and there is diminishing returns of marginal productivity of capital. So these are the few assumptions on which the Solow model is based. Now let us have a look at the instruments of this particular Solow growth model, right? So first of all, this is called the neoclassical growth model, right? So this is the neoclassical growth model, right? And here we try to explain the long run growth of an economy, right? And how do we try to show the long run growth? Via the capital accumulation. Like, what is the role of capital accumulation in technological progress, in driving the economic growth? So this is the objective of the model. So if we state it, then the model emphasizes the role of capital accumulation and technological progress in driving economic growth over time. Now let us discuss some key features. So number one is about, in order to find out that level of capital accumulation where there is steady state equilibrium. So in a Solow growth model, a steady state equilibrium is what? It is the amount of capital accumulation at which the growth rate, right? The delta K, that is the growth rate, is exactly equal to the investment, that is S into Fk. So that is the point, right? So let us see what it has to say. The key feature of Solow growth model is the concept of steady state, which is a state of equilibrium where growth rate of output per capita. So when we say growth rate of output per capita, so I'm talking about small y, right? It is constant. The model predicts that in the long run, an economy will reach a steady state where the capital stock per worker, output per worker, and consumption per worker are constant. So this is one important implication, right? So where is the point of steady state equilibrium? At the steady state equilibrium, that is the amount of capital accumulation K star. At that point, what are the things that should be equal? So that is your capital stock per worker, that is your K by L, output per worker, that is your Y by L, and consumption per worker, that is again your C by L. These all should be constant. Now this model assumes that there are three factors of production: labor, capital, and technology, right? And technology is basically exogenously given. Now the production function here is subject to diminishing returns. That means the more capital is added, the marginal product of capital will decrease. That is, if we write down, then the production function is y is equals to function of K comma L. Okay, so this is basically your production function, Solow growth production function. Now here the assumptions are MPK is positive excuse me, MPL is positive, right? And these two, that is MPK and MPK, are diminished. That means this is less than 0 and this is less than 0. Now in this model there is constant returns to scale. Now let us try to show how can I transform this model and show a production function which is constant returns to scale, and that is what is used in order to explain the Solow growth model. Okay, so we will take this production function, correct? Now in order to show constant returns to scale, let us change L and K by lambda proportion. Okay, so then in this case what will happen? After changing it by lambda proportion, what do we get? You will get, since this is CRS, this exhibits CRS, so it should be lambda y is equals to function of lambda K comma lambda L. So this is your constant returns to scale. Now let lambda is equals to 1 by L. So this is the value of proportion. Then your production function will become y by L is equals to function of k by L, comma L by L. Now this can be written as this y by L is output per worker, that is small y is equals to function of, let's say, small k. Now this is a production function with respect to per unit of labor that exhibits constant returns to scale, and here f dash k, that is your mpk, is positive and your mpk is diminishing. That is, with more addition of output, your returns, that is the mpk, will decrease. So this is the meaning. So like if we have a look at it, then it says that the model assumes that there are three factors, that is production, labor, capital and technology. Now the production function is assumed to be subject to diminishing returns, meaning as more capital is added, the marginal product of capital decreases. So one of the limitation of the Solow's model is that it does not fully explain the sources of technological progress, right? It just says that it is exogenously given, but how we are getting the progress, how is this capital getting accumulated, how is this change taking place, that is not explained. So this is a key driver of long-term economic growth. The model assumes that technological progress occurs exogenously, hence this is also the exogenous model, right? So that is outside of the model's framework and does not provide an explanation or how it arises or how it can be stimulated. So this is the limitation, and this limitation is taken care of in the next model, that is the endogenous model, where it has been explained that technology is not something which is determined from outside, or it is already given and we are using it, but it is something which is actually within the system, and within the system there is a change, and there are investment that takes place in the form of human capital, right, economies of scale and etc. So there are so many reasons behind which there is more technological progress, and this is certainly because of the determinants of within the system and determined with the change, and not just simply given exogenously. So this is one of the limitation of Solow growth model, which is explained in the endogenous model, which is just the next model after the Solow model, right? Now this was the first limitation. Now let us talk about the second limitation. What is the second limitation? So another limitation of the model is that it assumes that all the economies have the same steady state level of income per capita, regardless of their initial level of capital or technology. So this assumption ignores the fact that some economies may have advantage in terms of natural resources or technological capabilities that allow them to achieve higher level of economic growth. That means it is trying to say that this model already assumes a given amount of technology with which the economic growth is taking place, and neglects or ignores any other possibility that there can be change in the technological progress within the system with which there can be more economic growth, and it is not just given or fixed in amount. So this is the second limitation. Then what about the third one? So Solow growth model does not take into account the factors such as government policies, institution, human capital, which can all have important effect on the long-term economic growth, right? So additionally, now Solow growth model does not take into account factors such as government policies, institutions and human capital, which can have important effects on the long-term economic growth. So if we conclude, then in Solow growth model, it provides a useful framework for understanding the role of capital accumulation and technological progress in driving long-term economic growth. However, the model has several limitations, including inability to fully explain the sources of technological progress and its assumption that economies have the same steady state level of per capita. So these limitations are later explained in the endogenous growth model. So that's all for this answer.